very good morning to all of you children. Today we will discuss an important topic, electric potential and potential difference. Now, what is electric potential? What makes electric charges to flow? If you think that it is potential that makes electric charges to flow. Now we can compare this with flow of water. Now if we take a tube in which water is there, so if the tube is perfectly horizontal, then water will not flow through it. But if you tilt it, then there it creates a pressure difference. Here at the lower end pressure is high in comparison to the upper end due to gravity, and then water will flow through the tube. Similarly, in wire, the current itself not flow. Now to flow the charges, we create a pressure difference between the two ends of the wire through a cell or battery. I am reading a few lines from NCERT book, Electric Potential and Potential Difference. You open page 201. What makes electric charges to flow? Let us consider the analogy of flow of water. Charges do not flow in a copper wire by themselves, just as water in a perfectly horizontal tube does not flow. If one end of the tube is connected to a tank of water kept at higher level, you all have seen that all water tanks are at the top of the house, such that there is a pressure difference between the two ends of the tube. Water flows out of the other end of the tube. For the flow of charge in a conducting metallic wire, the gravity of course has no role to play. So in case of wire, if you tilt the wire, the charge will not flow from upper end to lower end because gravity is not playing a role here. But the electrons move when there will be a electric pressure, and this is called potential difference. Now when I am going to explain the concept of potential difference, you can think in this way. Suppose we have a plus Q charge. I have written we have a plus Q charge, and due to charge, suppose there is a electric field around it. If we take a magnet, then there will be a magnetic field around it. Similarly, suppose due to this positive plus Q charge, there is an electric field around it. Now, suppose there is another charge at infinite distance. Suppose this is unit positive charge. Suppose this is unit positive charge. Now these are the points A, B, these are the points in electric field. And at infinite distance, at infinity, we have a unit positive charge. Now if you want to bring this charge to point B or to point A, you have to do some work, because they are of positive nature, they are like charges, so like charges repel, so you have to do some work. So suppose you are bringing this charge to point B in the electric field, and work done to bring this unit positive charge is WB. Similarly, if we bring this unit positive charge to point A, we have to do more work, because point A is close to this capital Q charge. So a potential at point B or potential at point A can be defined as work done per unit charge. So here we are writing potential. The symbol for potential is V. So I am writing potential at point B will be equal to work done in bringing the unit positive charge from infinity to point B. So work done per unit charge is the potential at point B. Similarly, if you want to find out the potential at point A, then at point A potential will be WA by Q. If you have to calculate the potential difference, then VA minus VB will be simply equal to WA minus WB by Q. This is the potential difference, and these are the potential at point A and potential at point B. So this is the concept that how we can define potential. So work done per unit charge is the potential at that point. You also draw this figure and write these things in your copy. Write it, then I will dictate a definition for it. Now you can also write WA is the work done in bringing unit positive charge from infinity to point A in an electric field. Similarly, you can write WB is the work done in bringing unit positive charge from infinity to point B. The difference will be point B. VA is potential. VA is electric potential at point A. Now write these lines children. The electric potential, write down the electric potential at a point, the electric potential at a point in an electric field. The electric potential at a point in an electric field is defined as the work done in moving a unit positive charge from infinity to that point, So this definition you have written about electric potential. Now write a definition for electric potential difference. Electric potential difference. For electric potential difference, you write the potential difference between 2 points. The potential difference between 2 points in an electric field is defined as the amount of work done in moving a unit positive charge from one point to the other. Now we will write an expression for it. Expression for potential difference. Expression for potential difference. So write, or you can suppose that if W is the amount of work done, W is the work done to move a q coulomb of charge from one point to another in an electric field, then potential difference between the 2 points will be simply W by Q. So write, if W joule of work has to be done to move a charge of q coulomb from one point to the other, then potential and difference V between the points will be, writing V is equal to W by Q. So this is a important formula. We will use this formula in numerical also, that V is equal to W by Q, where W is the work done and Q is the charge in coulomb. Now SI unit of potential difference. SI unit of potential difference is volt, and in symbolically we write capital V for volt, since the unit is based on the name of scientist. Now uh, there is an important question that define 1 volt. Write this question: define 1 volt. So how we can define 1 volt? If you remember this formula, with the help of this formula you can define 1 volt. We can say that, as you know, the SI unit of work done is joule and SI unit of charge is coulomb. So we can say that if 1 joule of work is done to move a charge of 1 coulomb from one point to another in an electric field, then potential difference between the points is said to be 1 volt. So simply remember this, and then you can frame a definition for 1 volt. You can write that if 1 joule of work is done to move a charge of 1 coulomb from one point to another in an electric field, then potential difference between the 2 points is said to be 1 volt. So write this definition, children, a very important definition. Right, if 1 joule of work is done, if 1 joule of work is done to move a charge, if 1 joule of work is done to move a charge of 1 coulomb, to move a charge of 1 coulomb from one point to another, from one point to another, then potential difference between the 2 points, then potential difference between the 2 points in electric field is said to be 1 volt, is said to be 1 volt. So 2 important formulas so far we have discussed. In last class we have discussed I is equal to Q by T, how to calculate current. Then Q is equal to number of electrons into charge on each electron, and this is the third formula, V is equal to W by Q. Now how we can measure the potential difference? So a device called voltmeter is used to measure the potential difference between the 2 points in an electric circuit. Now potential difference is measured by voltmeter, and voltmeter is always connected in parallel, to which we have to, in parallel we connect a voltmeter. What is series and parallel connection, that we will learn later in this chapter. But you must remember that if you have to measure the potential difference across any resistance, then you have to connect a voltmeter across it in parallel, and in comparison to ammeter, a voltmeter has a higher resistance. So write the potential difference, write these lines. The potential difference is measured by means of an instrument. the potential difference is measured by means of an instrument called the voltmeter. Called the voltmeter. So about voltmeter, you know, it is always connected in parallel. Write it. It is always connected in parallel across the points between which potential difference is to be measured. Across the points between which the potential P dot D dot potential difference is to be measured. And in comparison to a ammeter, it has higher resistance. It has a high resistance. So these 2 points you must know about a voltmeter. Now we will solve some of the questions based on this formula. So first question is, calculate the work done in moving a charge of 4 coulomb from a point at 220 volt to another point at 230 volt. So in this question, first write down the given things. Charge is given and the symbol for charge is Q. So Q is 4 coulomb and potential difference V1 is 220 volt and the potential difference of another point is 230 volt, isn't it? So these are the potential at one point and this is potential of another point. So potential difference, first calculate the potential difference. Potential difference V will be equal to V2 minus V1. So it will be 230 minus 220. So 10 volt is the potential difference. Now we know that V is equal to W by Q. So we have to calculate work done, calculate the work done. This is the question. So from this formula we can write W is equal to V into Q. So V is how much? 10, and charge is how much? 4 coulomb. So 10 into 4, so 40 joule. Although this question is very easy, but I am solving so that you know how to solve these questions. So work done will be 40 joule. So this type of question you can get, and giving another question. Question number 2. I think you all have done it. Must write it in your copy, all the things which we are discussing today. So next question is, how much energy is transferred? How much energy is transferred by a 12 volt power supply to each coulomb of charge? Which it moves around the circuit. How much energy is transferred? So SI unit of energy is joule. So again you have to calculate the work done. Energy is transferred by a 12 volt power supply. So V is 12 volt, and to each coulomb of charge, and Q is 1 coulomb. So again use same formula. V is equal to W by Q. So W is equal to V into Q. So it will be 12 into 1, so 12 joule. So very simple questions these are, and you have to just think about you have to catch the language of the question, what you have to calculate, and then simply write down the given things, use formula, substitute the value and simplify it. Now I will give some more question through WhatsApp. I will send you the figures of the question. And the next topic that we will discuss is circuit diagram. You are familiar with these symbols. I think in junior classes we have discussed, but I tell you to draw these circuit diagrams in your copy. This is table 12.1 on page 203, because if we draw a circuit diagram with the actual figure of the components, then it will take a very long time to draw a circuit diagram, and it is difficult also to draw the circuit diagram. That's why scientists have given symbols for the cell, battery, plug key, wire joint, bulb, resistor, variable resistance, ammeter, voltmeter. So if you go through this table, so many symbols are given. So you must draw the symbols of these components, and then I will give some questions based on these symbols to draw the circuit diagram. Okay children, we will discuss this much today.